it says consider any triangle, such as the one shown below. Can you draw a parallel line to one of the sides that might create some alternate interior angles? Our goal here is going to be to make a proof, that the sum of the angles in a triangle is always what? 180 degrees. And we're going to prove that fact, and we're not just going to state it, we're going to prove it. So I'm going to draw a line that's parallel to AB. Now it's always good when you're constructing a new line to draw it such that it goes through some point that might be important. Okay? We have A and B, which is already parallel to, so it's gonna, if it goes through A or B, it's all the same. So what's the other point on this picture? C. C. We're gonna draw a parallel line B that goes through C, like this. Now, if you didn't come up with that idea, I didn't give you enough information to come up with that idea, but I wanted you to think about it, okay? Because, you know, when they were first figuring this out, somebody eventually had to draw this picture, right? And one day, you know, God or whoever came down to them and said, this is how you prove it. You have inspiration, and that can only come from a creative place. So now I'm going to take a look at these three angles. I'm going to call them X, Y, and Z, all right? Now that's the number of degrees here, so I'll mark it as degrees to remind you those are numbers for the numbers of degrees. We want to show that X, Y, and Z add up to what? 180 degrees. Well, we wanted to make some alternate interior angles. Take a look at X. Can you see where the alternate interior angle to that is? Well, here's our transversal, right? Oops. And we got two parallel lines.
It'll be right there underneath, like C and Y.
It's going to be up here. That angle is the same as X. These two are alternate interior angles. You see how they're alternate on opposite sides of this transversal?
Mm-hmm.
And they're squished in between this bottom parallel line and this top parallel line. So we have alternate interior angles here. So however many degrees this is also going to be that many degrees. Anyone see the other pair of alternate interior angles I can use here?
Z.
Z. Z and, well, we don't have a spot for it, but right here, right?
Yeah.
That's Z degrees. Now, X, Y, and Z. What do you notice about them now?
They are on a linear pair?
They are, well, you wouldn't say linear pair because there's three of them, right? But yes, they form a, well, linear set, I guess. They make up a straight line or a half circle when added all together. So, according to this, X plus Y plus Z is 180 degrees. Now, we can write a formal proof of this, but what I've just stated to you is the proof, right? These two angles are alternate interior to each other, and these two angles are alternate interior to each other. We know alternate interior angles are always congruent, are always the same. So, if this is X, then so is this. If this is Z, then so is this. So when I add them all together, X, Y, and Z, whether they come from the triangle or whether they come from here, they have to make the same amount. They still have to make 180 degrees. And that is our proof that no matter what triangle I use, I can always sort of flatten it out into a 180 degree line. So triangles always make 180 degrees. Questions on this? And you can review the video if you need to. That is going to be our major thing for today. We're going to do the isosceles triangle theorem tomorrow. But I want you to think about how you can use this in problems, right? Let's say that I've got a triangle where this angle is 70 degrees, this angle is 80 degrees. What does that make this angle has to be?
30.
30. And why 30?
Because 70 and 80 is 150.
So whatever is left over, right? You can add them together, and then you can use the skill we just practiced to immediately be like, boom, this is what's left over, right? You can do the same thing here with this one. Can someone tell me what goes here? That's 35 degrees.
70. No.
35, 55.
55. Is it 55?
No, 45.
45. So one of the things, so that's a common mistake actually, all the time. You think like, well, the two, if you do 55, right, you'll get straight to 90. Wait, no, it is 55. It is, let's just do this. 35 plus 55. 0, 1, 4. It's 55. Okay. Yes, it's 55. Notice, by the way, that these two add up to 90 degrees, right? So these two angles in a right triangle are always what to each other? Complementary, right. In a right triangle, you can think of the two acute angles as being complementary to one another. Let's do. Any questions on this right now? I'm going to give you a little challenge problem that's similar to what we looked at yesterday. Again, we're all working on this, thinking about it together. Oh, that's my 5 minutes to go. So this will be our last one. I'm going to put an angle right here. That's 135 degrees. This angle is 61 degrees. What is this one? And you gotta
Yeah, I had problems with these ones when I was trying to do it. I don't understand.
no, it's not 90.
It's 75.
75. No, we don't
Wait,
need-
I don't understand how you do it in general. Yeah, is it 75?
No.
It's something with the four.
Oh, wait.
Is it 74?
Is it 61?
74?
Yeah,
I think it might be 74.
I knew it was on with the four again.
Well, let's go through it.
Wait, hold on.
That's too many numbers in my head.
Oh, yeah, 74.
74.
Yeah.
It's
So
something
then how did you get 74?
Well,
I
called it out.
Folks, people aren't going to be able to hear this video. I need you to stop talking.
subtracted 180 minus 135.
Minus 135. And that gives you which angle?
That gives me this angle over here. Yeah.
And we don't have a label for it, so we'll say that one.
45.
So that's 45 degrees. Yep.
45 plus 61 is.
That's 61.
Oh, okay.
45 and 61 is 106.
And then I subtracted. I subtracted 180 minus 106.
Because the whole triangle has to equal up to what?
108.
Notice that it's not like 135, 61. You can't just pull the numbers out of nowhere, right? You can't just take 135 and 61 and add them together and expect that that's going to help. But what you can do is find out the complement or supplement of each angle. So here's the reason we wanted to find this angle. We know triangles have to add up to 180 degrees, right? There's still like 2 minutes left, guys. Don't need to pack up. 135. And then what's missing here has to make 180 degrees, right?
Right.
I called out the answer first.
What?
I called out the answer first.
I believe you.
Because since it's on a straight line, that means it's 180.
It's 180.
135.
All right, I think we're good. I think we've got enough for the video.
Okay.